Hello everyone, myself Mrs. A.P.MORE. I'm here to tell you some basics of feedback amplifiers. What is a feedback? A feedback is a process where a portion of the output of the amplifier is fed back and recombined with the input. We have two types of feedback amplifiers: positive feedback and negative feedback. What is a positive feedback? A positive feedback is a process where the output of the amplifier is added to the input with the help of the feedback circuit. So you have the amplifier here. The output of the amplifier is given to the feedback circuit, and the output of the feedback circuit is added along with the input back to the amplifier, and this process continues. Negative feedback. In a negative feedback, the output of the amplifier is fed back to the input through the feedback circuit. The input and the output of the feedback circuit are subtracted and given to the input of the amplifier. We have the negative feedback gain. A is the gain of the amplifier. Beta is the feedback factor. So to find out AF, that is the gain with feedback, we have XO, which is equal to A times XI. We have XF, that is the feedback signal, which is equal to beta times XO. And XI, that is the error input signal or the difference signal, is the difference between XS and XF. So AF, that is the overall feedback, is XO upon XS, that is output signal upon the source signal, which is equal to A upon 1 plus beta times A. So the quantity A beta is equal to the loop gain, and the quantity 1 plus beta A is the amount of feedback. Some of the advantages of negative feedback are stabilization of gain, reduction in nonlinear distortion, reduction in the effect of noise, extended bandwidth of the amplifier, modification of the input and output impedances. Now, what is stabilization of the gain? It means that it makes the gain less sensitive to the changes in the circuit components due to the changes in the temperature. The reduction in non-linear distortion makes the output proportional to the input, keeping the gain constant independent of the signal level. The reduction in the effect of noise minimizes the contribution to the output of unwanted signals generated in the circuit components or interference. Extended bandwidth means if there is reduction in the gain, there is increase in the bandwidth. And the last one, modification of the input and output impedances, raises or lowers the input and output impedances by selection of appropriate feedback topologies, which we will be seeing in the next slides. The disadvantages of the negative feedback. One of the major disadvantages of negative feedback is reduction in the circuit gain. Now we will see the basic structure of the feedback amplifier. In this, we have the amplifier, the basic amplifier with transfer gain A. The output of this amplifier is given to the sampling network, where the output signal is sampled and applied to the input of the amplifier through the feedback network. The output of the feedback network is mixed with actual input signal and given to the input of the amplifier. So as you can see here, you have the basic amplifier with transfer gain A. Then you have the sampling network. Then we have the feedback network with transmission factor beta. And we have the mixer, which mixes the signal, source signal, along with the feedback signal, and the output is given to the basic amplifier. So now what is a feedback network? This block is usually a passive two-port network which may contain resistors, capacitors or inductors. Most often it is a resistive configuration. That means this feedback network consists of resistors. Sampling network, the output voltage over here is sampled by connecting the feedback network in shunt across the output. So this type of connection is referred to as voltage or shunt or node sampling. The next sampling network, where the output current is sampled by connecting the feedback network in series with the output. So this type of connection is referred to as current or series or loop sampling. Then we have the comparator or the mixer network, which is at the input side. Over here, the feedback network and the source are connected in series and there is a loop here. So this type of network is referred to as voltage or series or loop mixing. Another one is where the feedback circuit is connected in shunt across the source, and this type of network is identified as current or shunt or node mixing. So this is a node mixer or a shunt mixer or a current mixer. With the help of the comparator network and the sampler network, we have 4 basic feedback topologies. In this, the voltage mixing, voltage sampling, the mixing, here you can see is the sampler, here you can see is the mixer. So the sampling network is in shunt with the feedback network. So this is voltage sampling, and at the input side we see that the feedback network is in series with the voltage with the source. So it is series mixing or voltage mixing. Okay, so this type of a network or a topology is called as series shunt topology, wherein the sampler is in shunt and the mixer is in series. It is also called as voltage amplifier with series feedback. The next type of feedback topology is current mixing and current sampling. If you see here, the sampler is in series, so it is current sampling, and the mixer is in shunt, so it is current mixing. And this type of feedback topology is called as current amplifier with current shunt feedback, or you can call it as current shunt feedback amplifier. The next feedback topology is the voltage mixing current sampling, wherein the sampling network here is, if you see, the feedback network is in series with the output. So the sampler or the sampling network is current sampling, and at the input side the feedback network is in series with the source. So this type of mixing is series mixing or series mixing or voltage mixing, and this type of topology is called as transconductance amplifier with current series feedback. And the last one is a topology where the sampling network has, here we can see that the output is in shunt with the feedback network. So the type of sampling used is voltage sampling, and over here we can see at the input side that the feedback network is also in shunt with the source. So it is current mixing, and this type of topology is known as trans-resistance amplifier with voltage shunt feedback. So these were the 4 types of topologies. Here is an overview of the 4 basic feedback amplifier topologies. And these are the comparisons with respect to gain, input impedance and output impedance for all the 4 topologies. So I hope this video will be helpful to you to understand the basics of feedback amplifiers and feedback topologies. Thank you.